the apocalypse that froze time, when Earth became a giant snowball for 50 million years. If you were to stand on the surface of our planet 700 million years ago, you would not recognize it as Earth. You would believe, with absolute certainty, that you had been transported to a dead world, a desolate moon, orbiting a distant, indifferent star. There is no sound of crashing waves, for the oceans are sealed beneath a carapace of ice more than a kilometer thick. There is no rustle of leaves or the cry of animals, for the land is a barren wasteland of gray rock and white frost, utterly devoid of macroscopic life. The sky is a pale, washed-out blue, reflecting the blinding white glare of the surface below. The sun, slightly dimmer than it is today, offers no warmth, only a cold, illuminating light that reveals the magnitude of the catastrophe. This is the Cryogenian period. This is Snowball Earth. To understand how we arrived at this frozen apocalypse, we must rewind the clock to a time when the world was dominated by a single, massive supercontinent known as Rodinia. It was a barren place by modern standards, devoid of trees or grasses, inhabited only by microbial mats and simple organisms in the seas. But the planet was alive with geological fury. Deep beneath the crust, the mantle churned, and Rodinia began to break apart. This breakup was the catalyst for a chain of events so complex and devastating that it would nearly extinguish the flame of life forever. As the continents drifted apart, fresh basaltic rock was exposed to the atmosphere. This rock, chemically hungry, reacted with carbon dioxide in the rain, a process known as silicate weathering. It scrubbed the greenhouse gas from the atmosphere and locked it away in the ocean floor sediments. Simultaneously, the fragmented continents drifted toward the equator. In this tropical zone, the warmth and humidity accelerated the weathering process, pulling even more carbon dioxide out of the air. The Earth's thermostat was broken. The blanket of heat-trapping gases that kept the planet warm was being stripped away, layer by layer. The cooling began slowly at first, a gradual creep of ice extending from the poles. But then, a terrifying threshold was crossed. Ice is white. It reflects sunlight back into space. Dark ocean water absorbs sunlight. As the ice sheets grew, they reflected more solar energy, cooling the planet further, which in turn caused the ice to grow even faster. This was the runaway ice albedo feedback loop. It was a mechanical, unstoppable slide into oblivion. Once the ice sheets advanced past a critical latitude, roughly 30 degrees north and south, the momentum became irreversible. The thermodynamics of the planet collapsed. In a geological blink of an eye, the ice sheets from the north and south raced toward the equator, crashing into each other with the force of continents. The trap snapped shut. The entire globe was encased in ice. The silence that followed must have been profound. The hydrological cycle, the engine that drives weather and distributes water, slowed to a crawl. With the oceans capped, evaporation ceased. The clouds vanished, leaving the sky a stark, empty dome. Rain became a memory, replaced by a scant, dry snow that fell like dust upon the endless white plains. The average surface temperature plummeted to -50 degrees Celsius. At the poles, it was far colder. The Earth had become a solid ball of ice, floating in the black void of space. For the life that existed at the time, this was the end of the world. The photosynthetic organisms, the cyanobacteria and primitive algae that relied on sunlight, found themselves trapped in a dungeon of darkness. The thick ice blocked out the sun, turning the vast, life-filled oceans into black, anoxic tombs. Nutrients stopped flowing from the land. The food webs collapsed. Extinction occurred on a massive scale. The vibrant microbial cities that had thrived on the continental shelves were scoured away by grinding glaciers or starved in the crushing dark. Yet, life is stubborn. It is a persistent flame that refuses to be snuffed out. In this frozen hellscape, pockets of resistance held on. Beneath the ice, where the crust was thin, volcanic heat from the Earth's core bled into the ocean. Hydrothermal vents, spewing superheated, mineral-rich water, became oases of warmth in a freezing world. Here, chemosynthetic bacteria huddled, drawing energy not from the sun, but from the chemical soup belching from the underworld. In other places, perhaps near active volcanoes piercing through the ice sheets, small pools of open water persisted, allowing just enough sunlight to penetrate for hardy algae to survive. There were likely slushy zones near the equator, ephemeral cracks in the ice armor, where the hardiest of single-celled organisms clung to existence, dormant, waiting, dreaming of a thaw that might never come. Time lost its meaning. The ice gripped the planet not for a century or a millennium, but for millions of years. 10 million, 20 million, 50 million years. The duration is difficult to comprehend. Entire mountain ranges were ground to dust beneath the shifting weight of the global glaciers. The geology of the planet was paused, suspended in a cryonic state. If an alien astronomer had looked upon our solar system during this time, they would have deemed Earth a dead planet, a failed experiment in the habitable zone. But while the surface was frozen, the heart of the Earth was still beating. The core remained hot, and the tectonic plates continued their slow, grinding dance. Volcanoes continued to erupt. Under normal circumstances, the carbon dioxide released by volcanoes is scrubbed from the atmosphere by rain and rock weathering. But on Snowball Earth, there was no rain. The rocks were sealed under ice. The geological scrubbing mechanism was broken. And so, the carbon dioxide began to accumulate. Molecule by molecule, ton by ton, the volcanoes pumped greenhouse gases into the stagnant atmosphere. With no way to remove it, the concentration of CO2 rose steadily. It took millions of years, a slow, invisible pressure building up against the cold. The atmosphere changed, becoming heavy with carbon, turning into a thermal blanket designed to trap whatever meager heat the sun provided. The levels of carbon dioxide rose to 300 times what they are today. The pressure was building. The planet was a time bomb waiting to detonate. The tipping point, when it finally arrived, was violent and abrupt. The greenhouse effect finally overcame the reflective power of the ice. The temperature began to rise. As the ice near the equator began to melt, dark pools of water were exposed. These dark patches absorbed the sun's heat, accelerating the warming. The feedback loop that had frozen the world now threw it into reverse. The melt was not a gentle spring thaw. It was a cataclysm. As the global ice sheets collapsed, they unleashed mega hurricanes, storms of a magnitude that the modern world has never seen. The atmosphere, supercharged with heat and moisture, churned violently. The evaporation from the newly exposed oceans was intense. Torrential acid rains, formed from the carbon-heavy atmosphere, scoured the land, dissolving rocks and washing massive amounts of nutrients calcium, magnesium, phosphorus into the oceans. The world swung from an icebox to a sauna in a geological instant. Temperatures soared to nearly 50 degrees Celsius. The oceans, effectively stagnant for millions of years, were suddenly mixed by the violent storms and flooded with nutrients from the ravaged continents. For the survivors, the microscopic organisms that had endured the long, dark winter, this was manna from heaven. The sudden influx of nutrients, combined with the return of sunlight and warmth, triggered a biological explosion. Cyanobacteria bloomed in quantities visible from space, pumping oxygen into the water and the atmosphere. The chemistry of the oceans changed fundamentally. The stage was set for the next great act in the drama of life. It is no coincidence that shortly after the end of the Snowball Earth events, the fossil record shows the emergence of the first complex, multicellular life forms, the Ediacaran biota, strange, soft-bodied creatures that looked like quilted pillows and fronds, appeared in the seas. The extreme pressure of the freeze had acted as a filter, an evolutionary bottleneck that selected for only the most resilient and adaptable cells. The chaotic, nutrient-rich aftermath provided the fuel they needed to grow, to experiment, to combine. The Snowball Earth did not just nearly kill all life. It likely drove the innovation that led to the evolution of animals. It forced life to get creative, to find new ways to survive, leading to the development of cell-to-cell communication and cooperation. As we look back at this frozen chapter of our history, we are reminded of the terrifying fragility of our climate's balance. We exist in a narrow band of stability, sandwiched between the freezing void and the boiling runaway greenhouse. The Earth is not a static stage, but a dynamic, sometimes violent entity. The ground beneath our feet remembers the weight of the ice. The DNA in our cells remembers the cold. We are the descendants of the survivors, the children of the thaw. The story of Snowball Earth is a testament to the resilience of our planet and the life it harbors. It teaches us that even in the deepest despair, when the world seems dead and buried, there is a fire burning deep within, waiting for the moment to break the ice and start anew. It is a story of destruction and rebirth, a cycle that has played out over eons to bring us to this moment, standing on a warm, green world, looking back at the time when the Earth was a white ghost in the dark. The evidence lies in the rocks, in Namibia, in Death Valley, in the Flinders Ranges of Australia. Geologists find the telltale signs: dropstones, foreign rocks, dropped by melting icebergs into marine sediments in places that were once tropical seas. They find layer upon layer of carbonate rock, capping the glacial debris, the chemical fingerprint of the massive CO2 buildup and the subsequent acid rainwash. These silent stones tell the story of the fire and the ice. They tell us that the blue marble we cherish was once a white one, and that the history of life is a story of survival against all odds. So the next time you feel the warmth of the sun on your face, or watch the waves crash against the shore, remember the white silence. Remember the time when the sun looked down upon a mirror and the waves were still. Remember the snowball, and be thankful for the melt. For without that great freeze, and the fire that followed, the complexity of life as we know it, the very consciousness that allows us to ponder our past, might never have come to be. The Earth froze, and in doing so, it paved the way for us to rise. Thank you so much for watching all the way to the end. If you enjoyed this video, learned something new, or simply want to see more content like this, please give it a like and subscribe to the channel. Your support truly helps the channel grow and reach more people. And if you have thoughts or ideas you'd like to share, feel free to leave a comment. I'd love to hear from you. See you in the next video.